In August of 2012, something strange happened to a spacecraft 18 billion kilometers from the Sun. The steady rain of particles it had flown through for years, the ordinary stuff blown outward by our own star, dropped away almost to nothing in a matter of days. And in that same handful of days, a different kind of particle, the high-energy cosmic rays flung out by dying stars far across the galaxy, came flooding in around it. Voyager 1 had crossed a line, but the line made no sense. The magnetic field around the craft grew stronger, and yet it never turned the way every model said the true edge of the Sun's realm should turn. Voyager had entered a region that matched nothing anyone had predicted, a place with no name, so a name was invented for it, the magnetic highway. It was the first hard sign that the space beyond our Sun is not the empty nothing it is assumed to be. And Voyager was still moving outward, toward places we have barely begun to have words for at all. The question is, what is actually out there? Tonight, we are going to follow Voyager 1 out past the edge of everything the Sun controls, into the region with no name and the stranger places beyond it, and find out what is really there. By the end of this, you will understand what Voyager actually crossed into, how impossibly far away it now is, where it is heading across the next 40,000 years and long after, and why the space between the stars turned out to be nothing like the empty void we expected. I am also going to tell you the part that is rarely said out loud, which is that Voyager is dying, and that when its voice finally goes quiet, we lose our only set of senses in that place, with nothing built to replace them. This is less a story about a machine leaving home than about the one thin thread still connecting us to the outside, and how little time it has left. If you like drifting out to the edge of what we know late at night, a quick subscribe brings more of these your way. Now, let us begin. Right now, as you listen to this, there is a machine more than 25 billion kilometers from the Sun, still moving outward, still calling home. That is Voyager 1, and the first thing to understand about it is the sheer scale of where it has got to, because the numbers stop meaning anything unless you slow down and let them land. 25 billion kilometers is more than 160 times the distance from the Earth to the Sun. The Earth to Sun distance already dwarfs anything in human experience, a gap so wide that sunlight, moving at the fastest speed there is, takes 8 minutes to cross it. Voyager is more than 160 of those gaps away. From out there, the Sun is no longer a sun in any ordinary sense. It is simply the brightest star in a completely black sky, a hard white point among the others, giving almost no warmth at all to the cold craft drifting away from it. Hold on to the fact that it is still calling home, because that is the thread this whole story hangs from. Voyager speaks to us by radio, and radio waves travel at the speed of light, the same light that takes 8 minutes to reach us from the Sun. From Voyager, that signal now takes around 23 hours to reach the Earth, nearly a full day. When the craft sends a reading, that reading spends most of a day crossing the dark before anyone here can catch it, and a command sent back out takes just as long to arrive, so a single question and its answer are almost 2 days apart. In November of 2026, Voyager will reach a distance of 1 full light day from Earth, meaning its signal will take a solid 24 hours to cross the gap, the first object humanity has ever placed that far into the dark. Every scrap of what we know from out there arrives as this one faint voice crawling home across a day of empty space. And it is moving away from us at about 17 kilometers every second. Not 17 an hour, 17 every second, which is faster than anything carrying people has ever flown, fast enough to cross the width of a country between 2 breaths. It has been running at that speed for nearly 50 years, since it launched in the 1970s, and it is still going, adding another few hundred million kilometers to the gap every single year. Nothing we have ever built has gone so far or so fast, and nothing is catching up. Voyager 1 is by a wide margin the most distant object human hands have ever made, and it is getting more distant with every second that passes. And yet, for all of that, it has barely begun. This is the humbling part of the distance, the part that puts the whole thing in proportion. Voyager is more than a light day from home, which sounds enormous, and is by every human measure, but the nearest star to the Sun is more than 4 light-years away, which is to say more than 1,500 times further than Voyager has managed to travel in nearly 50 years of flight. At the speed it is going, if it were even aimed at the nearest star, which it is not, it would take something like 80,000 years to get there. So the farthest we have ever reached, the very edge of what our species has physically touched, is a distance that light crosses in a single day, while the nearest neighbouring star is a distance that same light takes more than 4 years to cross. We have not left the doorstep. After 50 years and the fastest machine we could build, we have made it barely off the front step of the Sun's own realm and out into the first thin layer of the dark. That is not a criticism of Voyager, but a measure of how large the dark truly is, and of how astonishing it is that we can hear anything from out there at all. And hearing it is its own quiet marvel, because by the time that faint signal has spread across 25 billion kilometers, it is so weak that catching it needs some of the largest radio dishes ever built, straining at the very limit of what they can detect, reaching for a whisper measured in fractions of a billionth of a watt. The wonder is not that the voice is fading. The wonder is that across a gulf like that, we can still hear it at all. And that in the end is why a small team on Earth fights so hard to keep this one old craft alive. It is not sentiment, though there is sentiment in it. The real reason is that Voyager is irreplaceable in the most literal sense. It is the only working instrument our entire species has beyond the edge of the Sun's bubble, the single point from which any direct measurement of the true beyond can still be made. Lose it, and we do not lose one probe among many. We lose the only one there is, and the only one there will be for a long time. So every reading it sends back is, in a way, precious far beyond its content, because it comes from the one place we can no longer reach and can barely still hear. There is a loneliness to that which is hard to shake. Out there, further than anything, a cold machine turns its dish back toward a pale point of light it can no longer really see, and keeps talking, faithfully, into a silence that will soon be all there is. It does not know it is alone. It does not know anything at all. But we know, and that is enough to make the thin thread of its signal feel like one of the most valuable things we have, right up until the moment it stops for good. Now here is the part that most people do not know, and it changes how you hear everything that follows. Voyager is dying. It is not broken, and it did not crash into anything. Instead, it is simply running out of power, slowly and irreversibly, and it has been for years. Voyager makes its electricity from heat, the heat given off by a lump of slowly decaying plutonium buried in its body, and that heat fades a little more every year, by about 4 watts of power annually, with no possible way to top it up. Out there is no sunlight to run on, no way to refuel, nothing to draw from. The craft has only the dwindling warmth it launched with, and that warmth is nearly spent. To stay alive at all, it is being switched off piece by piece, instrument by instrument, system by system, and the day is coming, within a few short years, when there will not be enough left even to keep the radio running. When that happens, the voice stops, and there is nothing out there to take its place. So this is the strange situation we are in. We have exactly one working set of senses beyond the edge of the Sun's realm, one craft that has ever sent back a direct reading from that far out, and it is old, and it is cold, and it is fading towards silence even as we speak about it. Everything I am going to tell you tonight, every fact about what lies beyond our Sun, comes from that one dying machine and its slightly younger twin, and from almost nothing else, because there is almost nothing else out there to ask. Which brings us to the real question, the one that makes Voyager worth 2 hours of your night. Somewhere along its outward path, that craft crossed out of the Sun's territory entirely, and into a place we had never directly touched before. And when it did, it started sending back readings that broke our models and forced scientists to invent new words for what it was seeing. To understand what it crossed into, though, you first have to understand the thing it spent 35 years crossing out of, because the Sun does not end where the planets end. The Sun's realm is far larger and far stranger than the neat little map of planets we grew up with, and Voyager spent most of its life just trying to reach the edge of it. So let us start there, with the enormous invisible bubble we all live inside, and that Voyager had to escape before it could find the thing with no name. Before we leave the sheer distance behind, sit with what that communication delay really means, because it tells you how alone this craft is. On Earth, when something goes wrong with a machine, you can reach it, adjust it, stop it. With Voyager, if something goes wrong, the news of it takes 23 hours to arrive, and by the time engineers understand the problem and send a fix, another 23 hours pass before that fix even reaches the craft, and then more time still before anyone learns whether it worked. A single exchange with Voyager is a 2-day conversation across a silence so wide that the craft is, in every practical sense, on its own out there. It has to keep itself pointed at a pale dot of a homeworld it can barely detect, hold its dish steady, manage its own dwindling warmth, and answer when called, all without any real help, because help is always at least a day away. It is the most remote and self-reliant thing we have ever set loose. And it is worth remembering what that craft is carrying, because it says something about the moment it was made. Bolted to its side is a golden record, a disc engraved with sounds and images of the world that built it, greetings in dozens of languages, music, the noise of rain and heartbeats, meant for no one in particular, flung into the dark on the slim chance that something, someday, might find it. Voyager was launched by a species that did not yet know whether it could even reach the edge of its own solar system, and it packed a message for the stars anyway. That craft has already done more than anyone promised it would. It photographed the storms of Jupiter and the rings of Saturn, and then, on its way out, it turned its camera back one last time and took a photograph of the Earth from beyond the outer planets, a single pale blue dot, lost in a band of scattered sunlight, smaller than a pixel, the whole of human history balanced on a fleck of light. Then the cameras were switched off to save power, and Voyager put its back to us and kept going into the dark. That was decades ago. Since then it has done the thing it is truly remembered for, the thing this whole video is about. It kept going until it ran clean out of the sun's realm and into the space between the stars, and it started sending home readings from a place no object had ever been. But to understand the strangeness of what it found, you have to first understand the size of what it left, because the edge of the sun's territory is nothing like where you think it is. The sun does not end at the last planet. It does not end anywhere near it. The neat diagram of the solar system we all learnt, the sun in the middle and the planets in their rings out to Neptune, is not the edge of the sun's realm at all, but barely the beginning of it. The true territory of the sun reaches more than 3 times further out than Neptune, and it is not defined by the planets, but by something invisible pouring off the sun in every direction at once. To understand what Voyager crossed, you have to understand this first, because Voyager spent 35 years, most of its life, simply crossing out of it. The sun does more than shine. It is constantly blowing, streaming a wind of charged particles outward from its surface in all directions, a thin gale of broken atoms travelling at hundreds of kilometers a second. This is the solar wind, and it never stops and never eases. It rushes outward past Mercury, past the Earth, past Jupiter and Saturn, past Neptune, filling an enormous region of space around the sun with a fast, thin, magnetized gas of the sun's own making. And as it blows outward, it carves out a colossal bubble, a zone of space that belongs to the sun and is swept clean of the material that lies between the stars. That bubble has a name. It is called the heliosphere, and everything you have ever known, every planet, every comet, every human being who has ever lived, sits deep inside it. We do not live around the sun so much as inside the sun's exhaled breath, in a bubble it blows and holds against the pressure of the galaxy outside. The heliosphere is difficult to picture because it is so large, so let me anchor it. The solar wind rushes outward at great speed for a very long way, but it cannot rush forever, because eventually it runs into the thin material of interstellar space, pushing back, and it has to slow down. The place where it slows is the first great boundary Voyager crossed, and it is called the termination shock. Here the solar wind, which has been screaming outward faster than sound can travel through it, slams abruptly to a subsonic crawl, piling up and heating and turning turbulent as it meets the resistance of what lies beyond. Voyager 1 crossed that shock in 2004, at a distance of about 94 times the Earth to Sun gap. Let that sink in. The place where the Sun's wind first begins to lose the fight against the galaxy is more than 90 times further from the Sun than we are, more than 3 times beyond Neptune, and it took the fastest craft we ever launched 27 years of flight just to reach it. Crossing the termination shock did not put Voyager outside the Sun's realm. It only put it into the outermost layer of the bubble, a churning, hot, slow region called the heliosheath. Think of the heliosphere as having a calm, fast-flowing interior, where the solar wind streams smoothly outward, and then, near the edge, this turbulent outer shell where the wind has slowed and bunched and grown chaotic, sloshing against the boundary with interstellar space. The heliosheath is where the Sun's wind goes to die, piling up and swirling in the last stretch before the true edge, and it is thick. After crossing the termination shock in 2004, Voyager spent another 8 years pushing through the heliosheath before it reached the actual outer skin of the bubble. 8 more years just to cross the outer shell. So the real shape of the Sun's realm is nothing like the schoolroom diagram. Picture it instead as a single enormous bubble, blown by the Sun's wind, reaching out more than 3 times beyond the last planet, with a fast, smooth interior, then the shock where the wind slows, then the turbulent heliosheath, and finally an outer skin where the Sun's breath finally gives way to the space between the stars. Voyager launched, flew past the giant planets, and then spent the entire rest of its long life crawling outward through this structure, layer by layer, toward the edge. When people say Voyager left the solar system, this is the thing it was actually leaving, not the planets, which it had passed decades earlier, but the Sun's whole enormous bubble of wind. I should be honest that we are still working out the exact shape of that bubble, because it is genuinely hard to know from the inside. We have only ever measured the heliosphere along 2 thin lines, the paths traced by Voyager 1 and its twin Voyager 2, which crossed the edge in a different place and a different year. From 2 narrow samples, we are trying to reconstruct the shape of the whole thing, and the answer is not settled. For a long time we pictured the heliosphere as a rounded bubble with a long tail streaming behind it, like the wake behind a boat, shaped by the Sun's motion through the galaxy. More recent work has suggested it might be squashed and lobed, something closer to a crescent than a sphere. We do not fully know, because we cannot get outside it to look, and the only 2 probes that have ever crossed its edge did so at 2 single points. The Sun's own bubble, the thing we all live inside, is a shape we are still guessing at. There is one more piece of the bubble worth knowing, because it tells you the Sun is not sitting still in the gas but ploughing through it. As the Sun moves through the local cloud, it pushes the interstellar gas ahead of it, the way a slow boat pushes a swell of water ahead of its bow. For a long time, scientists expected this to raise a sharp bow shock in front of the heliosphere, a standing wall of piled up gas like the crack ahead of an aircraft going supersonic. But measurements of how fast the Sun is actually moving through the cloud came in lower than expected, slow enough that no sharp shock forms, only a gentler bow wave, a soft swell of gas heaping up on the leading side of the bubble. So even the very front of our bubble turned out to be a subtler thing than the diagram drew, a swell rather than a shock. One more case of the real edge being softer and stranger than predicted. And we did not have to take Voyager 1's word for the boundary alone, because its twin followed it out. Voyager 2 launched just before Voyager 1 but sent the long way round past more planets, crossed the heliopause itself in 2018, 6 years after its sibling, at a completely different point on the bubble and in a different direction. And crucially, Voyager 2 still carried a working instrument that Voyager 1 had lost decades earlier, a detector able to measure the density of the surrounding plasma directly on the spot. So when Voyager 2 crossed, it caught the jump in density at the boundary cleanly and directly, confirming from a second place what Voyager 1 had been forced to piece together indirectly. 2 craft crossing the edge of the sun's realm years apart and far apart, both finding the boundary, both finding the denser gas beyond. It turned the story from one strange, lonely track into something solid, an edge that is real, and real in more than one place, sampled twice by two different machines. It is worth lingering on what the termination shock actually is, because it is one of the more violent places in the whole solar system, and almost no one has heard of it. All the long way out from the sun, the solar wind has been rushing outward at supersonic speed, hundreds of kilometers a second, thin and fast and cold. At the termination shock, it meets the pressure of the interstellar gas and can push no harder, so it piles into itself, slams from supersonic to subsonic in an instant, and the energy of all that motion turns into heat. The gas beyond the shock is suddenly hot, slow, and turbulent, churning where a moment before it streamed. When Voyager crossed it in 2004, the craft's instruments caught the change sharply, the wind faltering and heating around it. The first real sign that the sun's outward push was finally losing its long fight with the galaxy. And out at the very edge of the bubble, there is thought to be a stranger feature still, a so-called hydrogen wall. As the interstellar hydrogen atoms drift toward the heliosphere and pile up against its outer skin, they bunch into a thickened band of gas draped across the front of the bubble, a wall of hydrogen where the inside meets the outside. Telescopes have found hints of exactly this kind of pile-up around other stars, other bubbles blown by other suns, glowing faintly at their leading edges. So our own bubble very likely wears one too, a shroud of heaped hydrogen at its nose, one more layer in a boundary that keeps turning out to have layer upon layer the closer we manage to look. What we do know is where the trouble started, where the readings began to break the models, and that came at the very outer edge of this bubble, just before the true boundary. Because as Voyager pushed through the last of the heliosheath, it crossed into a region that no one had predicted and no one had a name for. The particle counts did something no model had drawn, and for the first time, the people tracking the craft found themselves looking at data from a place they could not classify, at the very lip of the sun's realm. That is where we go next, to the region with no name. In the middle of 2012, Voyager crossed into something that no one had predicted, no model had drawn, and no one had a name for. This is the literal heart of what tonight is about, the place with no name. So let me show you exactly what happened, because it is stranger and more specific than the phrase suggests. For years, deep in the heliosheath, Voyager had been swimming through a steady sea of particles. There were the low-energy particles made inside the sun's own bubble, churned up and accelerated by the turbulence of the solar wind, and Voyager had measured them more or less constantly for a very long time. And there were the high-energy cosmic rays, the ferociously fast particles flung out across the galaxy by exploding stars, which mostly get held back at the edge of the heliosphere, so that only a trickle of them reaches the inside. That was the ordinary state of things, a strong, steady count of the sun's own particles, and only a thin drizzle of galactic cosmic rays leaking in from outside. Voyager had been reading those two numbers for years, and they had barely moved. Then, in the space of days, both numbers went haywire at once. The count of the sun's particles, the ones that had been Voyager's constant companion, suddenly plunged, dropping away toward nothing, as if the craft had sailed off the edge of the region that made them. And in the very same days, the galactic cosmic rays, the fast particles from the dying stars of the wider galaxy, came flooding in, surging upward to the highest levels anyone had ever measured out there. It was as though a door had opened. The inside particles were pouring out, and the outside particles were pouring in, and Voyager was sitting right in the doorway. And then, strangest of all, it happened not once but 5 separate times over about a month. The craft crossed the boundary, then crossed back, then crossed again 5 times, as if the edge itself were rippling and shifting past the craft like a flag in a wind, the counts leaping and dropping each time it passed. Now that pattern alone was surprising, but it was the magnetic field that turned it into a genuine puzzle. When something crosses the true outer edge of the sun's bubble, the models were clear about what should happen to the magnetic field. The field carried outward by the solar wind, wound into a particular direction by the sun's rotation, should give way to the interstellar magnetic field beyond, which points a different way, so the field direction should swing round, clearly and unmistakably, marking the crossing. That is what everyone expected, and it did not happen. The magnetic field around Voyager grew stronger, noticeably stronger, exactly as you might expect near a boundary where things pile up. But its direction did not change at all. It stayed pointed the same way it had been, only firmer, smoother, straighter than before. The field lines had gone taut and orderly, and along those smooth, straight lines the particles could run freely, the inside ones streaming out and the outside ones streaming in, which is exactly the flood the counters had seen. So the scientists tracking Voyager were looking at something that made no clean sense. By the particle counts, the craft seemed to have reached the very edge, or crossed it. By the magnetic field, it had not crossed anything, because the field had not turned. They were in genuinely new territory, a region the models had never produced, and they had no name for it. So they made one, because the smooth, straightened field lines let particles pour along them like traffic on an open road, while inside the bubble, the particles had bounced around in every direction, as if stuck on tangled local streets. They called this new place the magnetic highway. More formally, it was named the heliosheath depletion region. Depletion because the sun's own particles had drained a way out of it. But the name that stuck, the one that catches what it felt like, was the magnetic highway, a channel at the very lip of the sun's realm, open to the galaxy, where the inside and the outside had begun to mix. And here is the honest, unsettling detail that made it even harder. At the time, no one could say for certain whether this magnetic highway was still part of the sun's bubble or already part of the interstellar cloud outside. The one instrument that could have answered it directly, the one that measures the density of the surrounding gas, had broken years earlier, back in the 1980s, and never worked again. The way that boundary rippled past the craft is worth pausing on, because it shows how alive and unsettled the edge really is. Voyager did not cross once and stay across. Over about a month it crossed back and forth 5 separate times, the particle counts leaping and dropping with each pass, as if the boundary itself were flapping slowly in a wind, sweeping over the craft and then retreating again and again. The edge of the sun's realm is no still wall. Instead, it is a restless, wavering surface, shoved outward when the solar wind gusts harder and pushed back inward when it eases, rippling like a sheet hung on a line, and Voyager happened to be sitting right where it snapped back and forth. That alone taught the scientists something they had not known, that the boundary is a moving thing, that where the sun's realm ends is not a fixed place but one that breathes in and out. And they were careful about it at the time, rightly so. When the team first described this new region publicly, near the end of 2012, they went out of their way to say that Voyager had not definitely left the solar system, that this was a strange and unexpected place, but that the last clue they were waiting for, the turning of the magnetic field, had not yet come. They did not want to plant a flag before they were sure, and they were not sure, because what they were staring at fit nothing anyone had predicted. There is something rare and honest in watching a group of experienced scientists look at readings from a place no one had ever been and say, plainly, we do not yet know what this is. That is what the magnetic highway was, for a while, a genuine unknown, sitting there in the data, waiting for the rest of the picture to arrive. Those flooding cosmic rays are worth understanding, because of where they come from and what it meant that Voyager could suddenly see them. Galactic cosmic rays are the fastest, most energetic particles in nature, atomic fragments whipped up to nearly the speed of light, and they are forged in the most violent events the galaxy has, above all in the blast waves of exploding stars flinging matter outward across light years. For the whole of its life inside the sun's bubble, Voyager had been shielded from most of them, the heliosphere holding back the flood so that only a fraction ever leaked through. When the count suddenly surged to its full level at the edge, it meant Voyager had reached the place where that shielding gives out, where the raw cosmic radiation of the galaxy pours in unblocked. For the first time, a human instrument was tasting the low-energy cosmic rays of the wider galaxy directly, the ones that never make it deep inside the bubble at all. That matters well beyond Voyager, because those same cosmic rays are part of the reason a bubble is worth having. Deep inside the heliosphere, among the planets, we are partly shielded from that radiation by the sun's wind and field. The surge Voyager measured at the edge is a direct look at what we are being shielded from, the level of galactic radiation just outside our protection. It is a preview of what the space between the stars is truly like for anything not tucked inside a bubble like ours, and a reminder that the calm we take for granted here among the planets is in part a calm the sun manufactures around us by holding the galaxy at bay. So Voyager had sailed into a region it could feel with its particle counters and its magnetometer, but could not fully taste, could not directly sample the gas around it, and the people back home were left arguing over readings from a place they could not even confidently locate on the map. Was Voyager inside or outside? In the sun's realm or the galaxy's? Nobody could say. It had crossed into somewhere real, somewhere no craft had ever been, and it did not fit any category anyone had. I want you to notice what actually reached us across all of this, because it is the thread I keep pulling on. Every bit of this, the plunging particle counts, the flooding cosmic rays, the strong, smooth field that would not turn, arrived here as a faint radio signal that had crawled for many hours across the dark from a craft 18 billion kilometers away. We only know that a region with no name exists at all because that thin voice kept coming, night after night, carrying its impossible numbers home. Voyager, alone at the edge of everything the sun holds, had found a door we did not know was there, and it told us, in the only way it could, one weak signal at a time. But a door to where? That was the question the magnetic highway left hanging. If Voyager had found the edge, or something like it, then the next thing to look for was the true crossing, the moment it left the sun's bubble entirely and entered interstellar space. That moment came, and when it did, it brought the strangest argument in the whole story, because the one clue everyone was waiting for refused to arrive. On the 25th of August, 2012, Voyager crossed the true edge of the sun's bubble and entered interstellar space. And almost no one believed it, because the one clue everyone was waiting for never came. By then, Voyager had been in the strange magnetic highway for months, and on that day in late August, the last of the changes arrived. The count of the sun's own particles, already low, fell away completely, dropping to essentially nothing and staying there. The galactic cosmic rays climbed to their full interstellar level and locked in, steady, no longer a trickle leaking through a barrier, but the ordinary background of the wider galaxy, as if the barrier were simply gone. By the measure of the particles, it was unmistakable. Voyager had left the region where the sun's wind holds sway. It had crossed the heliopause, the outer skin of the bubble, the true boundary between the sun's realm and the space between the stars. It was, for the first time in history, an object made by human hands drifting in interstellar space at a distance of about 121 times the Earth-to-Sun gap. But the magnetic field, again, refused to play its part. Everyone was waiting for the field to turn. That was the agreed signal, the last box to tick, the one clue that would settle it beyond doubt, the swing of the magnetic field from the sun's direction to the galaxy's. And it did not swing. Voyager crossed by every particle measure it had, and the magnetic field grew stronger and stayed pointed almost exactly the way it had been pointed inside. For a boundary that was supposed to announce itself with a clean turn of the field, this was maddening. So a real and public argument broke out, and it lasted for years. Some scientists said the particle evidence was overwhelming, that Voyager had plainly crossed, field or no field. Others said that without the field turning, you could not be sure that this might be some other structure, some deeper pocket of the bubble, and that the craft had not truly left. For a long time there was no consensus at all about whether the most important boundary crossing in the history of space exploration had actually happened. The resolution, when it came, was subtle and rather beautiful, and it tells you something about how strange the edge really is. The reason the field did not turn, the best understanding now holds is that the interstellar magnetic field just outside the bubble is not free and undisturbed. Instead, it is draped over the heliosphere and dragged into line with the sun's own field, bent and combed in the same direction by the presence of the bubble it is flowing around, the way a current bends around a stone. So in the region just outside the boundary, the galaxy's field happens to point almost the same way the sun's field does, and it does so not through any failure of Voyager to cross. The two fields are simply pressed into alignment right there at the border. It was a muddied zone, a place where the inside and the outside look alike because the outside has been shaped by the inside. And that meant Voyager, though it had crossed the heliopause, was still not in clean, pristine, undisturbed interstellar space. It was in a bent and blended border region, and it would go on travelling through that muddied zone for years more before it reached the genuinely undisturbed medium beyond. That last point is worth holding because it is happening right now. By some of the best estimates, Voyager was not expected to reach truly pristine interstellar space, the clean, undisturbed medium, far enough out that the sun's influence on the local field finally fades until around 2025, which means that only in the last stretch, only very recently, has Voyager perhaps begun sampling the real, unshaped space between the stars, as opposed to the border zone still combed by the bubble it left behind. The craft has spent more than a decade crossing a boundary that turned out to have depth and structure and layers of its own, a frontier region rather than a line. I have to be fair about how unfinished all of this still is, because the honesty is the point. Even now, some researchers argue about exactly where to draw the boundary, about what the non-turning field really means, about which of Voyager's crossings was the true one. The edge of the sun's realm did not turn out to be a clean line you cross once and are done. It turned out to be a wide, messy, layered zone, a magnetic highway, then a heliopause that announced itself in the particles but not the field, then a long muddied border region, and only lately, perhaps, the clean space beyond. We drew a single line on our old maps and called it the edge of the solar system. Voyager went there and found not a line, but a whole complicated country of boundaries, and it is still, even now, working out where it truly is. One thing worth saying is how genuinely contested this was, because from here, it is easy to smooth it into a tidy discovery. For a couple of years after 2012, there were respected scientists who simply did not accept that Voyager had crossed, who argued in print that the craft was still inside the bubble, caught in some deep, unexpected pocket of it, and that the true crossing was still ahead. The disagreement was not petty. It went to the heart of what counts as proof, whether the overwhelming change in the particles could settle the matter on its own, or whether the stubborn refusal of the magnetic field to turn meant the case stayed open. This is what real frontier science looks like from the inside, not a clean flag on a clear line, but years of argument over ambiguous readings from a place no one can go and check. What finally tipped it was, in part, the craft catching a different kind of evidence entirely. Some months after the August crossing, a burst from the sun rolled all the way out to Voyager and set the gas around it ringing, and the pitch of that ringing gave a direct reading of how dense the surrounding gas had become, and the answer was unmistakably an interstellar one, far denser than the inside of the bubble. That was hard to argue with, and later, when Voyager 2 crossed in a wholly different direction carrying a working density detector, and measured the same kind of jump cleanly and immediately, the last of the reasonable doubt fell away. Voyager 1 had crossed after all. The particles had been right the whole time. The magnetic field had simply been bent into a shape that hid the crossing, a final trick played by an edge that seemed determined to be stranger than anyone was ready for. There is a cruel timing buried in all of this that is worth drawing out. For more than a decade after the crossing, Voyager was travelling through that bent and muddied border zone, where the interstellar field is still combed into line by the bubble it had left, not yet the clean, undisturbed space beyond. By the best estimates, the craft was only expected to reach genuinely pristine interstellar space, the real unshaped medium, at some point around the middle of this decade, which means Voyager may be arriving in the very region we most wanted it to sample, the true undisturbed beyond, at almost exactly the moment its instruments are being switched off one by one for lack of power. We spent 35 years getting it to the edge, then over a decade more carrying it through the messy border, and just as it reaches the clean water on the far side, it is running out of the power to tell us what is there. It is the kind of timing that would seem too bleak to write into fiction, and yet it is simply where we are. So the honest picture of the crossing is not a single triumphant moment, but a long, layered, still unfinished passage. Voyager crossed the magnetic highway, then the heliopause, then years of muddied border, and only now perhaps the clean interstellar medium. And at every stage the edge turned out to have more depth and more structure than the last. There was never a line. There was a country, a wide frontier region with its own internal boundaries, and Voyager has been slowly traversing it for the whole span since we first announced it had left. Even the simplest question, where does the sun's realm end, turned out to have not a place for an answer, but a process, one the craft is still living through as its voice fades. One more thing about that crossing deserves saying, because it surprised even the people who expected it. When Voyager 2 finally crossed the heliopause 6 years later, in a completely different direction, far to the south of where Voyager 1 had gone, it crossed at very nearly the same distance from the Sun, only a little further out. 2 probes, heading out on paths pointing to different parts of the sky, both reached the edge of the bubble at almost the same range. That hinted the heliosphere is more evenly rounded, at least on those 2 sides, than some of the lopsided shapes had suggested, the bubble holding a fairly steady thickness in the directions the Voyagers happened to travel. It is a small thing, 2 numbers turning out close, but it is exactly the kind of thing you can only learn by actually going, by pushing real craft through the real edge in more than one place and comparing what they find. A model can propose a shape, only a crossing can measure 1, and we have now measured 2, and no more are on the way. So set aside the argument about exactly which crossing counts. By any reasonable measure, Voyager is outside the sun's bubble now, in the space between the stars, which raises the question that reframes the whole story, the one the thumbnail points at. Now that it is out there, in the true beyond, is it drifting through empty nothing at last? Is interstellar space the perfect void we always pictured? Voyager is the first thing that has ever been able to answer that from the inside, and the answer it sent home was not the one anyone expected. Interstellar space is not empty. That is the finding that should reset how you picture everything beyond the sun, and Voyager measured it directly the moment it got outside. The void is not a void at all, but a place, with substance and structure and something close to weather. Here is how we know. Space between the stars is filled, thinly, with plasma, which is gas that has been stripped of some of its electrons so that it carries an electric charge. It is desperately thin, thinner than anything we would ever call a vacuum on Earth. But it is there, and it is real, and it has a density you can measure. Inside the sun's bubble, near the edge, that plasma is at 1 level. When Voyager crossed the heliopause and got outside, the density of the plasma around it jumped, and not by a little. It rose by roughly 40 times denser on the outside than at the edge of the bubble it left. The space between the stars, the supposed emptiness, is markedly thicker with matter than the outer reaches of the sun's own realm. Now, I want to be careful and honest about scale, because 40 times a very small number is still a very small number by human standards. The interstellar medium holds on the order of 1/10 of a charged particle per cubic centimetre, which is to say, you would have to gather up a volume of space the size of a beach ball to find a small handful of particles in it. By any earthly measure, that is still an astonishing, near-perfect emptiness, far emptier than the best vacuum we can make in a laboratory. So I am not telling you the beyond is thick like fog. I am telling you that it is far denser than the bubble Voyager left, and far denser than nothing, and that this thin charged gas has real physical presence. It has pressure. It pushes on the sun's bubble from outside. It is a substance, a medium, an actual sea that Voyager is now swimming through, not an absence. And the deeper surprise is that this sea is not smooth or uniform. Voyager has found that the density is not the same everywhere. As the craft has pushed further out, the plasma around it has on the whole been getting denser still, a gradual thickening the further it goes from the sun. Why the density should climb as you move outward, no one fully understands, but Voyager measures it steadily. More matter around it, the deeper into the beyond it travels. And on top of that overall trend, there are smaller fluctuations, gusts and lulls, patches where the gas thickens and thins over short distances, the fingerprints of turbulence in the interstellar medium. The space between the stars churns and eddies on its own scales, stirred by the slow violence of the galaxy, by the shock waves of ancient exploded stars still rolling through it. It is not a still, dead, uniform emptiness. It has texture. It has structure. It has, in a real sense, weather, moving through it far too slowly for us to feel but plainly there in Voyager's readings. This is the thing I most want to overturn in your picture of the beyond, so let me put it plainly. When we imagine interstellar space, we imagine perfect black nothing, an infinite still vacuum in which the stars hang like lamps. That picture is wrong. The truth is that we live inside one bubble of thin gas, blown by our sun, floating in a wider sea of thin gas that belongs to the galaxy. And that wider sea is denser than our bubble, and it flows, and it varies, and it presses in on us from every side. Voyager did not sail out of a full region into an empty one. It sailed out of the sun's thin bubble into the galaxy's thicker sea, and the crossing was a step up in density, not a step into the void. The emptiness we always pictured is in fact the least empty place the craft has ever been on the far side of the planets. I have to be honest that we understand this new sea only in the barest outline, because of how little of it we have actually touched. Everything I have just told you comes from two thin sample lines, the single track of Voyager 1 and the single track of its twin, threaded through an unimaginably enormous region. We know the density is rising along Voyager's path, but we cannot say with confidence what the larger structure looks like, whether the craft happens to be heading into a denser patch, or whether the whole medium thickens this way everywhere. We are like someone trying to map an entire ocean by dragging a single thread through it and noting where the water felt colder or warmer along that one line. It is real data, the only direct data there is, but it is a thread through a sea, and the sea is almost entirely unknown. Let me give you the actual numbers, because they make the reframe concrete. Inside the heliosphere, out near its edge, the charged gas is desperately thin, only a few thousandths of a particle in a cubic centimetre. Outside, in the interstellar medium, Voyager measured roughly 8/100ths of a particle per cubic centimetre, and climbing. That is the 40-fold jump. Both numbers are almost nothing by any earthly standard. Both are emptier than the finest vacuum we can build in a laboratory. And yet the outside is unmistakably, measurably, the thicker of the two. To feel the gulf, consider that the air you are breathing holds something like 10 billion particles in every cubic centimetre. The interstellar medium holds a fraction of one. The difference between them is almost beyond holding in the mind. And still, that fraction of a particle is not zero, and Voyager can feel it, and the difference is real, and it matters. There is more out there than the charged gas too. Drifting through the interstellar medium are neutral atoms, whole and uncharged, mostly hydrogen and helium, and some of these sail right into the heliosphere as though the boundary were not there at all, because, being uncharged, they are not turned aside by the magnetic fields that deflect everything else. These interstellar atoms blow through the entire solar system as a faint, steady wind, coming from the direction the sun is heading, and instruments much closer to home have tracked that wind for decades, a thin breeze of the galaxy passing right through the planets. So the beyond is not sealed off behind a wall, it leaks in. We are not only floating in a bubble surrounded by the interstellar sea, we are, in a small and constant way, being blown through by it, threads of the galaxy's own gas drifting silently among the planets even now, even here. The rising density along Voyager's path is one of the real puzzles it has handed us, and no one is quite sure what it means. You might expect that as the craft moves away from the sun's bubble, deeper into interstellar space, the gas would settle to some steady background level. Instead, it keeps thickening. More matter around the craft the further out it goes, a gradient that climbs and climbs. Perhaps Voyager is heading into a denser patch of the local cloud. Perhaps the region just outside the bubble is compressed by the bubble's own pressure and thins as you go further out. Perhaps it is something about the boundary we do not yet grasp at all. We simply do not know, because we have only this one thread of measurements to reason from. And a single thread pulled through an ocean cannot tell you the shape of the whole current. And the turbulence carries its own quiet significance, because the churning of the interstellar medium is tied to the largest workings of the galaxy. The gas between the stars is stirred by the shock waves of dead stars, shaped by magnetic fields, gathered and compressed in some places until it collapses into new suns and scattered thin in others. The eddies Voyager feels as it drifts are small local ripples in that enormous, slow process, the same process that, given enough gas and enough time, builds stars and worlds. So the faint gusts in the gas around a dying probe are not nothing. They are the far edge of the machinery that makes stars, felt directly, for the first time, by a thing small enough and far enough out to notice them. It is worth holding on to how strange it is that emptiness comes in degrees at all. We tend to think of empty as a single thing, a yes or a no, either there is matter or there is not. But space taught Voyager otherwise. The inside of the sun's bubble is one kind of near-nothing. The interstellar medium beyond is a thicker kind of near-nothing. Deeper into the galaxy, in the cold, dark clouds where stars are born, the gas grows thicker still, thousands of times denser than the wisp we sit in, though even that would be a fierce vacuum to us. And out in the great voids between the galaxies, the emptiness deepens past anything nearby, a few atoms in a space that could swallow the whole solar system. So the beyond Voyager entered is neither the emptiest place there is, nor the fullest, only one particular rung on a long ladder of emptiness, and the craft is the only thing we have ever sent to stand on that rung and read it. Every number it returns is a measurement of exactly how empty one specific stretch of the galaxy is, and that, it turns out, is a real and answerable question, not a poetic one. No one had ever been able to ask it of the true beyond before, and after Voyager, for a long while, no one may be able to ask it again. Still, one thing is now certain that was only a guess before. The beyond has substance, and if it has substance, a thin charged gas pressing all around the craft, then a natural question follows, one that turns out to have a genuinely strange answer. Can Voyager, adrift in that gas, actually hear it? Can a thing measure the sound of the space between the stars? The answer is yes, and what it hears is one of the eeriest signals ever sent home. Voyager can hear the space between the stars, not with sound in the way we mean it, because sound as we know it cannot travel through gas this thin, but with something close enough that the scientists who study it use the word without flinching. The interstellar gas rings, and Voyager listens, and what it sends home is a faint, steady tone from the dark between the stars. Here is how a thing hears a place that thin. The plasma out there, the charged gas, behaves a little like the surface of a pond. Disturb it, and it does not just move, it oscillates, the electrons in it sloshing back and forth at a particular rate, ringing like a struck bell. And the pitch of that ringing depends directly on how densely the electrons are packed. Pack them tighter, and the ringing rises in pitch. Spread them thinner, and it drops. So the frequency of that oscillation is a direct readout of the density of the gas, a note whose pitch tells you exactly how much matter is out there. Voyager was built with the means to catch it. It carries two long antennas, each about 10 meters from end to end, stretched out from its body, and they were designed precisely to pick up these plasma waves, to catch the ringing of the gas around the craft. When the interstellar medium rings, Voyager's antennas feel it, and the craft turns that ringing into a number and sends the number home. For years, though, Voyager could only hear the gas when something struck it hard enough to make it ring loudly. That something was the sun. Every so often the sun throws off a great outburst, a violent gust in the solar wind, and that gust rolls outward through the whole solar system, reaches the edge of the bubble, and pushes on out into the interstellar medium beyond, where it slams into the thin gas and sets it ringing like a bell struck by a hammer. Scientists came to call these events a kind of tsunami, a wave from the sun crashing out into the gas between the stars, and each time one arrived, months after leaving the sun, Voyager would hear the interstellar medium ring out loud and clear, and from the pitch of that ringing, measure the density. It worked, but it depended on the sun. You had to wait for a storm, wait for the wave to travel out, and only then could you hear the gas, in bursts, whenever the sun happened to shout loudly enough. And then, more recently, Voyager began to hear something else, something far quieter and far stranger. Underneath the loud occasional tsunamis, in the long silences between them, the craft picked up a faint, thin, persistent tone, a narrow, steady note humming away in the gas even when the sun was quiet, even when nothing was striking the medium at all. The interstellar gas, it turned out, is ringing softly all on its own, all the time, a background hum too weak to have been noticed before. And Voyager, out in the true silence beyond the sun's noise, was finally in a position to hear it. It is faint, and it is monotone, a single low steady note, the sound of the space between the stars simply being what it is. And because it is always there, Voyager no longer has to wait for a solar storm to measure the density. It can read the gas continuously now, moment to moment, listening to the pitch of that constant hum and knowing, at every step, exactly how thick the medium is that it is moving through. A live, unbroken readout of the beyond carried on a note the galaxy hums to itself. There is something in that image I cannot quite get past, and I do not think I am supposed to. A small, cold, dying craft, alone in the dark beyond every star we have ever named as neighbourly, its home a pale dot it can barely find, sits in the thin gas between the stars and listens to it hum. And then it gathers that hum into a signal and sends it back across 18 billion kilometres and more, a full day of travelling light, so that we, on the surface of a warm blue world, can hear what the emptiness sounds like. The whisper that reaches us is no longer only telling us that we crossed into the unnamed, it now carries home the actual voice of the beyond, the steady ringing of the gas that fills the space between the stars, relayed to us by the one machine far enough out to catch it. Let me mark the honest edge here too, because it matters. We know the hum is real, and we know what it tells us, the density of the gas, but we are not entirely certain what physically produces it. It may be the gas quietly ringing from its own warmth, the thermal jostling of the particles, or it may be some other subtle process at work in the medium. To settle it would take more, perhaps a future probe built for the job. So we hear the note clearly, and we read it well, but we cannot yet fully explain why the beyond hums at all. That too is waiting out there, unanswered. There is an old, romantic idea that space is silent, that the void is the one truly quiet place, and in the ordinary sense that is true, because there is no air out there to carry a sound to an ear. But the gas between the stars is not truly still. It rings, it carries waves, it hums to itself in the dark, a real physical vibration in the thin charged medium. And we know this only because we placed a listening thing far enough out to feel it. The silence of space turned out to be, in part, a kind of deafness on our side, a matter of never having had ears in the right place. Voyager gave us those ears, once, briefly, near the very end of its life, and through them we have heard the faint steady note of the emptiness, and learnt that the emptiness was never quite as empty or as quiet as we had always believed. And there is a strange intimacy in the way that sound reaches us. The gas rings out there, 25 billion kilometres away, far beyond every planet, in a place no living thing will ever stand. Two thin antennas on a cold and dying craft feel that ringing and turn it into a number. The number is folded into a radio signal weaker than a small bulb, and flung back across the dark, spreading and fading for a full day, until a great dish on the earth, straining, catches the ghost of it and pulls the number back out. And only then, at the end of that impossible chain, do we get to know how densely the gas is packed in a place we will never go. Every reading of the hum is a small act of listening across a gulf so wide it barely makes sense, and the fact that it works at all, that we can sit on a warm world and hear the emptiness between the stars ring, is one of the quietly astonishing things our species has ever managed. There is a strange patience to how these signals arrive. When the sun throws off one of its great outbursts, that gust does not reach Voyager for the better part of a year, sometimes longer, because even at the speed of the solar wind, the edge of the bubble is enormously far away. So the craft drifts in silence, and then, many months after some storm on the sun that we had half forgotten, the shock finally reaches the interstellar gas and sets it ringing, and Voyager hears the delayed echo of a solar event that happened most of a year before. It is a little like hearing thunder from a storm that has already passed and moved on, except that the delay is measured in months and the distance in tens of billions of kilometers. And listening across the years, the scientists notice something that ties back to everything else. The pitch of the ringing has on the whole been slowly climbing. Higher pitch means denser gas, and a rising pitch over time means the gas around Voyager is growing steadily thicker as it travels, the same rising density gradient heard as a slowly sharpening note. So the hum is not only telling us how dense the beyond is at any one moment, followed over years, it is singing the story of a craft moving into ever thicker gas, a note climbing slowly higher as Voyager sails deeper into the interstellar sea. It is, in the most literal way, the sound of the beyond changing around the very thing we sent out to listen to it. When the people who study these signals shift the plasma waves into the range of human hearing so that we can actually listen to them, the result is genuinely eerie, a thin, steady whistling drone, a single sustained tone with a faint texture riding on it, unlike anything born on Earth. That is the nearest thing there is to the actual sound of interstellar space. The closest a human sense can come to being out there. It is not silence, and it is not noise, but a pure, cold, unwavering hum, the note of the emptiness itself, and it has been playing out there the whole time, through the entire span of human history, waiting for something to be far enough out to hear it. For a few years, one small craft has been. When it goes quiet, that sound does not stop. The gas will go on ringing its steady note between the stars exactly as before. We will simply no longer have anything positioned to catch it, and the hum of the beyond will go back to being a thing that happens with no one listening, the way it was through all the ages before we sent an ear. For now, hold the picture we have built. Voyager is outside the sun's bubble, in a sea of thin charged gas that is denser than the bubble it left, textured with gradients and turbulence, and humming a faint steady note the craft can hear and relay home. But where, in the larger structure of the galaxy, is all of this happening? What is this sea, and how does it sit around us? To answer that, we have to pull the camera back, further than we have yet, and look at the strange nested arrangement of shells and bubbles that we and Voyager are actually sitting inside. And when you see it, the story stops being about a distant probe and starts, quietly, to be about us. We are not sitting in open space. We are sitting inside a cloud, and that cloud is sitting inside a far larger bubble, blown clear by the deaths of stars, and the arrangement is not just a piece of trivia about our address. Rather, it is the thing that turns this whole story from a distant curiosity into something that reaches back and touches us directly. Start with the cloud. The Sun, and all the planets, and Voyager along with them, are currently passing through a wispy region of warm interstellar gas about 30 light-years across. It has an unglamorous name, the local interstellar cloud, though some people call it the local fluff, which is a better name for how thin and diffuse it is. It is a loose drift of gas, mostly hydrogen and helium, warmed to several thousand degrees, so sparse that it would count as a fine vacuum by any earthly standard, and yet dense enough to matter, dense enough to press on the sun's bubble from outside and help shape it. The sun did not always sit inside this cloud. It drifted into it at some point in the last 100,000 years or so, and it will drift out again in another 10 or 20,000, because the cloud and the sun are moving through the galaxy on their own separate paths and merely happen, for this stretch of cosmic time, to be passing through each other. We are, right now, sailing through a particular cloud, and it is not permanent, and it is not the only one. Now pull back further, because that cloud is itself sitting inside something vastly larger. The local interstellar cloud is one small wisp within an enormous cavity in the galaxy called the local bubble, a region at least 1,000 light-years across, where the gas is far thinner than the galactic average, scoured out and swept nearly clean. And we know what cleared it. The local bubble was blown open by supernovae, by a series of exploding stars that went off within the last 10 to 20 million years, their blast waves sweeping outward and pushing the gas of the galaxy into a great thin shell, leaving a hollow behind. We are living inside the cavity carved by dead stars. Our whole neighborhood, every nearby star you can see, sits within this bubble of unusually empty space that a handful of ancient supernovae excavated long before there were humans to notice. So the true picture of where we are is a nesting of shells. Our heliosphere, the sun's own bubble of wind, sits inside the local interstellar cloud, which sits inside the local bubble carved by supernovae, which sits within the great disk of the Milky Way. One shell within another, and we are down at the center of the smallest one, and Voyager has only just pushed out of that smallest shell into the cloud beyond. There is a genuine mystery in the cloud we are passing through, and it is worth knowing, because it shows how unsettled all of this still is. By rights, the local interstellar cloud should not really be here at all. The supernovae that blew out the surrounding local bubble should have swept this wispy little cloud away, along with everything else, crushed it, or scattered it to nothing millions of years ago. And yet it persists, a coherent drifting wisp, sitting inside the great emptied cavity, holding together where it ought to have been torn apart. The best explanation anyone has is that the cloud is more strongly magnetized than expected, threaded through with its own magnetic field that lends it enough internal strength to resist destruction. Voyager 2, in fact, helped uncover this, measuring a surprisingly strong magnetic field just beyond the bubble, stronger than the models had allowed for. So the very cloud we are sailing through is something of a survivor, a fragile thing that outlived the blast that should have erased it, and we happen to be crossing it during the narrow stretch of its existence. We are learning the shape of all this not only from the Voyagers, but from a small spacecraft much closer to home, orbiting the Earth, that maps the edge of the sun's bubble in a clever, indirect way. It catches the atoms that come flying back inward when the solar wind smashes into the interstellar gas at the boundary, and from that steady return of atoms, it builds an all-sky picture of the entire skin of the heliosphere, seen from the inside out. Between that map drawn from near home and the two thin threads the Voyagers have physically traced through the real edge, we are slowly, painstakingly piecing together a portrait of the bubble we live in and the cloud it floats in. But it is early work, and most of it is still unknown, and the Voyagers remain the only things that have ever actually touched the far side of the boundary. Let me make the stakes of this as concrete as I can, because it is the part that reaches back and touches us. In the most extreme scenarios, a cloud dense enough could compress the heliosphere so severely that its outer edge is pushed far inward, in the worst imaginable case, toward the region where the planets orbit, stripping away much of the shielding the bubble provides, and letting the raw radiation of the galaxy fall on the worlds inside far more heavily than it does today. That is the far end of the range, not something the gentle wisp we are in now would do. But it is a real point on that range, and it makes the general truth vivid. Our shield is no fixed wall bolted around us. Instead, it is a bubble whose size rises and falls with the pressure of whatever interstellar region we happen to be crossing, and we are, always, crossing. And we are not staying in this cloud. The sun is thought to sit near the edge of the local interstellar cloud already, close to its far side, and on the scale of tens of thousands of years, it will pass out of this wisp entirely and into whatever lies beyond, the next cloud, or the thinner gas between clouds, each with its own density and its own effect on the bubble. So the interstellar weather we live in is not a settled backdrop, but a slowly changing sky, and the thing that decides it is exactly the thing Voyager is out there measuring in its final years. When the craft reads the density of the gas climbing along its path, It is not gathering some abstract fact about the void. What it captures is the first direct measurement of the medium that sets the size of our shield. From inside that medium, at the one moment in all of history when we finally have a machine positioned to do it and are about to lose it. Here is the turn, and it is the moment this stops being someone else's story. The size of the sun's protective bubble, the heliosphere, is not fixed. Instead, it is a balance, a bubble held open by the sun's wind pushing out against the interstellar gas pushing in, and its size depends on how hard each side pushes. When the sun passes through a thin region, the outside pressure is low, and the bubble can inflate large. When the sun passes through a denser cloud, the outside pushes harder, and the bubble is squeezed smaller. And that matters to everything living inside it, because the bubble is not only a boundary, but a shield. The sun's wind and magnetic field, filling the heliosphere, hold back a large fraction of the galactic cosmic rays, those fast and damaging particles from exploded stars, keeping them from reaching the planets in full force. Shrink the bubble, and you thin the shield. Let the outside gas press in closer, and more of that hard radiation from the galaxy leaks through to where the planets orbit, which means that the character of the cloud we happen to be sailing through, the thing Voyager is out there measuring right now, helps set how much cosmic radiation reaches this world. The beyond is no distant backdrop with nothing to do with us. It is the very medium our shield pushes against, and as we drift from one cloud to another across the ages, that shield tightens and loosens in response. Sit with what that means, because it is the spike of this whole story. For most of tonight, the beyond has been out there, a strange place a distant probe is exploring, interesting but remote, someone else's frontier. And it is not. We are inside it, we are sailing through it. The same interstellar medium Voyager is tasting at the edge of its life is the medium whose pressure decides the size of the bubble that shields our entire world from the radiation of the galaxy. When Voyager measures the density of the cloud rising along its path, it is measuring the very thing that squeezes or relaxes our shield. The distance between out there and in here, which has felt so enormous all night, turns out to be no distance at all. The cloud Voyager is in is the cloud we are in. Its readings are, quietly, readings about us. I have to be honest that we do not know the timings or the effects with any precision. We are not even fully certain whether the sun sits squarely inside the local cloud or right at its edge, already half into the next region. Estimates for when we will leave this cloud entirely run to another 10 or 20,000 years, and what exactly a denser cloud would do to the climate and the living things of a world is real but genuinely hard to pin down. I am not telling you a disaster is scheduled. I am telling you that the shield we live behind is not a constant, that it breathes in and out depending on the interstellar weather we are passing through, and that the one instrument capable of measuring that weather directly from inside it is the fading craft we have been following all night, which makes the next questions almost unbearable to ask. Where is the sun sailing next? Into what kind of region? And how much longer does Voyager have to keep telling us anything about it at all? There is a clock running under all of this, one that decides how much longer any of it is even possible, and I promise I will get to it, but not yet. First, I want to show you where Voyager is heading across the next 40,000 years and what other unnamed places are waiting on the way. The sun is sailing toward the edge of the cloud we are in, and beyond that edge lie regions no instrument has ever touched. Voyager is not heading into more of the same. It travels, along with the whole solar system, out of one interstellar region and toward the frontier of another, and what waits there is genuinely unmapped. Right now, the sun appears to sit near the boundary of the local interstellar cloud, close to its edge rather than deep in its middle, and it is drifting toward an interface with a neighboring cloud, a region sometimes called the G cloud, off in the general direction of the center of the galaxy. When the sun crosses from one cloud into the next, the interstellar weather around us changes. The density shifts, the magnetic field of the surrounding gas may point a different way, the pressure on our bubble changes, and the shield tightens or loosens in response. And these two clouds are not the whole story either. Within about 30 light-years of the Sun, there are more than a dozen distinct wisps of gas like these, each drifting on its own path, each with its own density and temperature and direction, a whole scattered archipelago of cloudlets threaded through the thin reaches of the local bubble. As the ages pass, the Sun will drift among them, in and out of one cloud after another, and the space around us will keep changing in ways we are only now, thanks to Voyager, beginning to measure at all. These are the other unnamed places the title points toward, not one mysterious region, but a long succession of them, waiting along the road ahead. And here is where I have to be careful and honest, because there is a real edge to this, and also a great deal of overstatement floating around it. On far longer timescales, the kind measured in millions of years, the Sun has passed not only through thin warm wisps like the one we are in now, but through denser, colder clouds. And those are a different matter. The last time the Sun is thought to have passed through a genuinely dense, cold interstellar cloud was very roughly 2 million years ago. A cloud like that, far thicker than the local fluff, would press much harder on the Sun's bubble and could shrink the heliosphere dramatically, in the most extreme scenarios squeezing it down so far that the shield thins severely and a great deal more cosmic radiation reaches the planets. What that would actually do to a living world is where the honesty has to come in. It is a real mechanism. A denser cloud really would compress the bubble and raise the radiation reaching the planets. But whether past cloud crossings actually changed Earth's climate or drove any of the shifts in living things across its history is genuinely unsettled and argued over. There are hints, traces of the debris of nearby supernovae laid down in the Earth's crust at certain depths that the solar system has passed through the aftermath of stellar violence before. But a clean causal line from a cloud crossing to a climate shift to an event in the history of life is not something anyone has firmly drawn. So I will say the careful thing rather than the dramatic one. The shield breathes as we move through the galaxy. Denser regions can thin it. We have passed through such regions before, and will again, and what that does to a world is a real open question that no one has answered. That is the truth, and it is unsettling enough without inflating it. There is one line of evidence worth laying out with care, because it is real, and it is genuinely strange. Buried in the crust of the Earth, in the slowly building layers of the deep sea floor, scientists have found traces of a particular form of iron, iron 60, that does not form on Earth and is made instead in the hearts of exploding stars. It lies in thin bands at certain depths, matching certain times, most strikingly around 2 to 3 million years ago, and again further back. The most natural reading is that the solar system drifted through the expanding debris of nearby supernovae at those times, and that a faint rain of stardust carrying this telltale iron settled onto the Earth and was locked away in the rock. So we have, in the ground beneath us, a physical record that the solar system has passed through the aftermath of stellar violence more than once in its recent past. That much is solid. What is not solid, what no honest person will claim, is that these passages changed the climate or touched the course of life in any measurable way. The dust arrived. Whether it did anything at all is unknown. I lay it out because it is the real, grounded version of the alarm, far stranger and more honest than the inflated one. And there is at least a proposal for a successor, though only a proposal. Scientists have drawn up detailed plans for a dedicated interstellar probe, a craft built from the outset to fly out through the bubble and deep into the interstellar medium, faster and far better equipped than Voyager ever was, designed to pick up the map exactly where Voyager will drop it. It is a serious idea, studied in real depth, but it is not funded, not built, and not flying, and even if it launched soon, it would take decades to reach the frontier. For now it is a set of drawings and a hope, and the only things actually out there, actually reporting, are still the 2 aging Voyagers, and not for very much longer. We should be clear about how little we know of what lies immediately ahead, because it is genuinely close to nothing. The neighbouring region the Sun is drifting toward, the G cloud, lies off in the direction of the centre of the galaxy, and beyond the bare fact of its existence and its rough motion, we can say very little about it at all. We do not know its density in any detail, or its magnetic field, or exactly where the boundary between it and our own cloud sits, or what will happen to the heliosphere as we cross from one into the other. These are not distant abstractions. They are the properties of the space the entire solar system is about to sail into over the coming tens of thousands of years, and our knowledge of them is a scatter of faint measurements and a great deal of guesswork. That is the deeper meaning of the title, in the end. It is not only that Voyager crossed into one region with no name. The larger truth is that the whole road ahead of us, the long succession of clouds and cavities the sun will drift through across the ages, is very nearly unmapped, a chain of unnamed places we will enter one after another with almost no idea what waits in them. Voyager pushed a single thin probe a little way into the first of them and sent home the first real facts we have ever had. The rest is dark, and the one craft that could keep lighting even a small part of it is nearly out of power. We are heading into a long line of unknown regions, and we are about to lose our only means of seeing even the nearest one clearly. And the crossings themselves, when they come, will be slow and strange in their own right. When the sun finally reaches the edge of the local cloud and pushes into the next region, the change will not be a sudden boundary the way a coastline is. It will be a gradual shift over thousands of years, the density of the surrounding gas slowly rising or falling, the pressure on the bubble easing or tightening, the heliosphere swelling or shrinking by degrees in response. Nobody will be there to see a line crossed, because there will be no line, only a slow handover from one interstellar region to another, played out across a span longer than all of recorded history. And each such handover changes, gently, how much of the galaxy's radiation reaches the worlds inside the bubble. This is the true shape of the future the solar system is sailing into. Not a series of walls, but a series of slow tides in the surrounding gas, and the only craft that has ever measured that gas from within is the one whose power is nearly gone. None of this moves fast, and that is worth saying plainly, so the alarm stays honest. The sun drifts through these clouds at a stately pace, taking tens of thousands of years to cross from one region to the next, so nothing about the interstellar weather changes on any timescale a person, or even a civilization, would feel. The cloud we are in now, we will likely remain inside for another 10 or 20,000 years at the least. This is not a danger looming over anyone alive or their descendants for many generations to come. But that is exactly why the measurements matter now, rather than later. The changes are slow, yet they are real, and they are coming. And the only way to understand what a cloud crossing does to our shield is to have mapped the medium carefully before we are in the thick of one. Voyager is laying down the first survey markers of a terrain the solar system will be crossing for the rest of its existence. We will not need that map tomorrow, but if we ever want to understand the sky we are sailing into, someone had to begin drawing it, and Voyager is the one that began, and almost no one is set to carry the work on. What ties all of this back to the craft is simple. Voyager is drawing the first real map of the near part of this terrain. Every measurement it makes of the density and the magnetic field and the turbulence of the medium we are in is a first data point in understanding the environment our shield pushes against and how it might change as we move. It is charting the leading edge of a country the whole solar system is sailing into, a country of clouds and cavities and shifting pressures that will shape the radiation environment of this world across the long future. It is the scout, the first and so far only one, reporting back from the frontier of the interstellar weather we are all riding through. But Voyager itself is not staying near us. Follow its own path far enough, and it leaves the neighborhood of the sun entirely, and heads out across spans of time that dwarf everything we have talked about so far. The clouds and the shield and the shifting weather are the near future, the next tens of thousands of years. Voyager is bound for something much longer and much lonelier than that. Because while the solar system drifts slowly among its local clouds, Voyager is leaving on a path of its own, aimed at no world and no star, out into the deep galaxy, where it will keep going long after everything we have discussed tonight has changed beyond recognition. So let us follow the craft itself all the way out and see where the voice is actually going. Voyager is not going anywhere. That sounds like a strange thing to say about the farthest object we have ever launched, but it is the truth, and it is worth understanding, because the popular idea that Voyager is on its way to another star is simply wrong. Voyager has no destination. It is aimed at no world, no star, no place at all. It is only leaving outward forever, and that is a different and stranger fate than arrival. Its direction, for what it is worth, is toward the constellation Ophiuchus, out roughly in the direction the Sun itself is travelling through the galaxy, tilted up out of the flat plane of the planets. It is moving outward at a steady pace, gaining about 3.5 times the Earth-to-Sun distance every year, and it will simply keep on that heading, because there is nothing out there to stop it or turn it. In space, with nothing to slow you, you coast in a straight line essentially forever, and Voyager will coast. The closest it ever comes to another star is a genuinely humbling thing to contemplate. In roughly 40,000 years, Voyager will pass within about 1.5 light-years of a dim, faint star, a small, unremarkable dwarf catalogued with a number, rather than a name, drifting in the northern sky. And that is as close as it gets. 1.5 light-years is still 9 trillion kilometers, still hundreds of times wider than the entire span from the Sun to Neptune. It is not an encounter, not a visit, only the barest distant nod across an unbridgeable gulf, two objects passing in the enormous dark, neither ever knowing the other is there. Voyager will not slow, will not turn aside, will not signal. It will simply drift past, far off in the black, a cold, silent speck, sliding by a cold, faint star, tens of thousands of years from now, and then continue on, leaving even that lonely near miss behind. And after that, Voyager keeps going, out of the neighbourhood of the Sun, out among the general population of stars, and it becomes something almost beyond reckoning. It is bound loosely to the galaxy itself, held by the collective gravity of 100 billion stars, and so it will not fly off into intergalactic emptiness. Instead, it will settle into a slow orbit around the centre of the Milky Way, circling the galactic core once every couple of 100 million years, the way the Sun does, the way all the stars do. Voyager will become, in effect, one more object orbiting the galaxy, a tiny artificial mote among the stars, going round and round the centre for a span of time that makes the age of our whole civilization look like nothing. It will still be out there, cold and dark and silent, long after the Sun has swollen and died. It will outlast the Earth. It will outlast everything any of us has ever known, drifting on its slow galactic orbit, carrying its golden record of a vanished world, a message in a bottle thrown into an ocean so large that the odds of it ever being found are almost indistinguishable from zero. It is, quite possibly, the longest-lasting thing our species will ever make. Think about what it is carrying on that endless drift. The golden record bolted to its side is not really a message anyone expects to be read. The chance of a craft the size of a small car being found in the enormous emptiness between the stars, by anyone, ever, is so close to zero that it is barely worth stating aloud. The record was never truly a letter to the stars. It was a mirror held up to ourselves, a way of asking what we would say if we had one chance to say anything at all to the universe, and choosing, in the end, to send greetings and music and the sound of rain and a human heartbeat and a mother speaking softly to her child. It says far more about the people who made it than it will ever say to whoever might find it, because almost certainly no one ever will. And it will carry that unheard message for an almost unimaginable span. Long before it is ever found, if it ever is, the Sun that made it will have changed beyond all recognition, swelling in a few billion years into a red giant, swallowing the inner planets, and settling down at last into a cooling ember, while Voyager, entirely indifferent, drifts on around the galaxy with its record intact, a relic of a star and a species both long gone. There is something almost unbearably lonely in that, and also something oddly steadying. Whatever becomes of us, this one small thing will still be out there, carrying the record of a single bright moment for longer than the Sun itself will shine. It is worth remembering how it came to be heading this way at all. up and out of the flat plane of the planets, because it was not the original plan. Voyager was built to tour the giant planets, and it did, spectacularly. In 1979, it swept past Jupiter and found, among much else, active volcanoes erupting on the moon Io, the first time anyone had seen a world beyond Earth, with volcanoes going off in real time. In 1980, it reached Saturn, and here the mission made a choice that set the whole rest of its existence. It could have gone on toward other planets, or it could swing in close to Saturn's giant moon Titan, wrapped in its thick orange air, to study it up close. It chose Titan, and that close pass, the gravity of the great moon bending its path, flung Voyager upward, out of the flat plane the planets travel in, onto a track that pointed away from any further worlds and out toward the stars instead. From that moment, its planetary tour was over, and its long climb into the dark had begun. So the path Voyager will follow for the rest of time was set almost by accident, a byproduct of choosing to look closely at one intriguing moon. There was no grand plan to aim it at any particular star, because there was no star worth aiming at within any reachable distance. It was simply flung outward in the direction the planets happened to leave it, and it has coasted on that heading ever since, and will coast on it essentially forever. The most far-travelled object our species has ever made is not going anywhere it was aimed. It coasts where a slingshot around one moon happened to point it, out into the general dark, on a road chosen not for any destination, but simply because it led away. There is a way of feeling the scale of Voyager's future that I find almost steadying, rather than bleak. Across the millions of years ahead, as it circles the galaxy, Voyager will pass other stars, never closely, but it will drift through the general neighbourhood of sun after sun. Each encounter separated from the last by spans longer than our species has so far existed. It will outlast the constellations. The patterns of stars we see in the sky tonight will drift and rearrange and become unrecognisable long before Voyager has completed even a fraction of one lap around the galactic centre. It will outlast the continents in their present shapes, outlast the steady middle age of the sun, outlast, almost certainly, the human species in any form we would know. And through all of it, it will simply coast, unpowered, unguided, silent, a small hard fact of aluminium and gold, moving in a line bent slowly into an orbit by the pull of 100 billion stars. Whatever we make of that, it is a genuinely new kind of permanence for something a living hand has built, and it began with a single pass by a moon. I should be honest that we cannot chart that deep future path with any precision. Over spans of tens of thousands and millions of years, the small gravitational tugs of stars it drifts near will nudge Voyager this way and that, and the exact orbit it settles into is not something anyone can predict in detail. What is certain is the shape of the fate, not the fine print of the route. It arrives nowhere. It is caught by nothing. It simply persists, outliving its makers by an almost unimaginable margin, a durable and permanent drifter in a galaxy that will never notice it. So here is the thing that this long view makes almost cruel. As an object, Voyager is nearly immortal. The physical craft, the aluminium and the gold and the cooling plutonium will endure for hundreds of millions of years, orbiting the galaxy in the dark, essentially forever by any human measure. And yet, at the start of tonight, I told you that Voyager is dying, and that is also true, and both things are true at once, because the craft and its voice are two entirely different things. The object will drift for aeons. The voice, the signal, the faint radio whisper that lets us hear anything it finds has only a handful of years left. Voyager, the drifting mote, will outlast the sun. Voyager, the listening, reporting, living instrument, is almost out of time. And that gap between the two, between the immortal object and the dying voice, is the clock this whole video has been circling. It is time, at last, to look at it directly. The voice is dying, and it is dying now, and there is a hard clock on it that nothing can reset. This is the thing I have been holding back, the clock running under everything, and it is time to lay it out plainly, because it changes what all of this means. Voyager makes its power from heat. Inside it sits a lump of plutonium, slowly decaying, giving off warmth, and that warmth is turned into a trickle of electricity. That is the whole power source. There are no solar panels, because out there the sun is just another star and gives almost nothing. There are no batteries to recharge, nothing to refuel, no way whatsoever to add power once it launched, and the plutonium fades. Every year the decaying lump gives off a little less heat than the year before, and so the craft has a little less electricity to work with, losing about 4 watts of power annually, a slow, steady, absolutely irreversible decline. Voyager has been running down like this for its entire life, and now, nearly 50 years in, it is scraping the bottom of what it has. So the engineers who keep it alive have been forced into a long, sad process of switching it off, a piece at a time, to keep the rest running. It is a kind of triage. Each year there is a little less power, so each year something has to go dark to save what remains. The cameras were switched off decades ago, right after the last photograph. Then, one by one, the heaters that keep various parts of the craft warm, and instrument after instrument. Voyager launched with 10 scientific instruments. 7 of them are now switched off for good. As of early 2026, only 2 are still gathering science: the magnetometer that measures the field and the plasma wave antennas that hear the hum of the interstellar gas. Just 2 out of 10 still awake. And even keeping those 2 alive is a fight, because the craft is now so starved of power that the engineers are running out of things left to sacrifice. They have shut off heaters that everyone assumed were essential, and watched, nervously, to see whether the exposed parts would freeze, and been relieved, for now, when they did not. Voyager is down to single systems with no backups left, everything running on its last string, no spare for anything. One more failure in the wrong place, and there is no fallback. The engineers have not given up, and what they are doing to wring out the last years is genuinely ingenious. They have worked out a plan, half seriously nicknamed the Big Bang, to switch several power-hungry systems off all at once and swap in lower power alternatives in one coordinated move, buying a stretch of extra life rather than losing instruments one at a time. They test each risky change on Voyager 2 first, the twin with a little more power to spare and a slightly shorter signal delay, before daring it on Voyager 1. Every watt is fought for, every heater left running is weighed against every instrument kept awake. It is triage, carried out with enormous care across a 2-day gap on a machine that can never be touched again, by people who know that each choice is very likely permanent, that once something is switched off out there in the cold, it can almost never be brought back. There is even a fragility in our ability to reach it at all. Only one radio dish on the entire Earth is powerful enough to send commands out to the Voyagers, a single giant antenna in the southern hemisphere. And for a long stretch recently, that very dish was shut down for upgrades, leaving the craft able to send data home, but nearly impossible to command for months on end. Sit with that. The most distant machine we have ever built, in the last years of its life, hangs on a single aging dish on one patch of one planet, and for a while even that one thin thread was cut. Everything about keeping Voyager alive is like this now, a chain of single points of failure, any one of which could end it on any given day, held together by the stubbornness of a small team who refused to let the voice go quiet a single day sooner than it must. There is a quiet grimness to the order in which the craft is being taken apart, because it was decided long ago, in advance, on paper. Years back, the science and engineering teams sat down together and agreed the sequence in which they would switch things off as the power ran down, which instrument would go first, which next, all the way to the end, so that the most valuable measurements would survive the longest. They are now working their way down that list. Each instrument that goes dark had measured something real, some aspect of the particles, or the field, or the gas, that simply stops being watched at all once it is off. The low-energy particle detector that had run almost without pause since 1977 was switched off only recently, after nearly half a century of continuous work, because its turn on the list had come. What remains awake now is only the field and the plasma waves, the last 2, kept for the end precisely because they are the ones still returning the most about the interstellar medium. And every one of these shutdowns is a small, permanent death. Out there in the cold, with no way to warm the electronics back up and no power to spare, an instrument switched off is almost certainly switched off forever. There is no turning it back on later when things improve, because things will never improve, the power only ever falls. So the people who run Voyager are not pausing its senses, they are ending them, one at a time, choosing in what order the craft is allowed to go blind, like someone deciding which lights to put out, one by one, across a place they know they are leaving for good and can never come back to. It must be among the strangest jobs anyone has ever had, and they do it with a care that borders on tenderness, for a machine that cannot feel any of it, because they alone understand exactly what is being lost. And the voice itself, the radio signal, is almost incomprehensibly faint. The transmitter on Voyager broadcasts with about the power of the small bulb inside a household refrigerator, 20-odd watts, and that feeble whisper has to cross more than 25 billion kilometers of space to reach us, spreading and weakening the entire way, until what arrives at the Earth is so faint it takes some of the largest radio dishes ever built straining to catch it at all. That we hear anything is a small miracle of engineering repeated every single day. And it very nearly stopped. In late 2023, Voyager suddenly began sending home pure gibberish, a stream of meaningless repeating nonsense instead of data. And for months it seemed the mission might simply end there, with the craft babbling incoherently into the dark. Engineers eventually traced the fault to a single failed chip in its aging memory, and, across a distance that made every attempt a 2-day round trip, painstakingly rewrote and relocated the affected code and coaxed the craft back to sense. It was an extraordinary rescue of hardware designed in the early 1970s and now further away than anything has ever been. But it was also a warning. The machine is old and frail, and every recovery is harder than the last. Put it together and the clock is brutal and clear. The engineers hope, if the power saving goes well, to keep at least one instrument alive into the 2030s and to hold some faint engineering signal a little longer. But the end is not a question of if, only of when, a matter of a few short years set by the plutonium and the watts, an arithmetic that cannot be argued with. Sometime soon, within years and not decades, the last instrument will go dark, and then the transmitter and Voyager will fall silent. Not because it broke, not because it hit anything, but simply because there was no longer enough warmth left in the plutonium to make itself heard. And when it does, there is nothing waiting to take its place. There is no other craft out there in interstellar space. There is no successor built and ready on the pad, no replacement funded and flying. When Voyager's voice stops, our direct contact with the beyond stops with it, completely, and for a long time. I want to leave one thing genuinely open, because it is a real question, and it is honestly yours to weigh, not mine to answer for you. If we wanted to keep our senses in the beyond, we would have to build and launch a successor now, or soon, a new probe aimed at the edge and beyond. But such a craft would take decades simply to get out there, to cross the bubble and reach interstellar space, which means many of the people who built it and launched it would be dead before it ever sent back its first reading from the far side. So here is the question: is it worth it? Is it worth pouring the effort and the money and the lifetimes into a machine we will not live to hear report, purely so that the generation after us, or the one after that, is not blind out there? Or is a probe whose whole purpose only pays off after its makers are gone simply not something a species will ever reliably choose to do? I have my own lean on it, but I think it genuinely belongs to you, and I would rather leave it open and honest than hand you a tidy answer. Because whatever we decide, one thing is now fixed. This voice, the one we have, is going quiet. Which leaves only the last question: what exactly do we lose on the day it does? So what do we lose on the day the voice goes quiet? The honest answer is more than most people would guess, because almost everything we directly know about the space outside our own bubble rests on this one dying craft, and when it stops, we do not arrive at a finished understanding. We stop in the middle of a sentence. Gather up everything we have learnt tonight and notice where all of it came from. That the edge of the sun's realm is not a line but a wide, layered, muddied frontier. That there is a region out there with no name, where the inside and the outside mix along smooth magnetic lines. That the space between the stars is not empty but denser than our own bubble, textured with gradients and turbulence. That it hums, faintly and steadily, a note the gas rings all on its own. That the cloud we are sailing through presses on our shield and helps set the radiation reaching this world. Every one of those facts, every single direct measurement of the beyond, comes from Voyager 1 and its twin, and from almost nothing else, because there is almost nothing else out there to ask. Two craft both dying are the entire basis of our first-hand knowledge of what lies outside the sun's bubble. Take them away, and what remains is models, guesses and inference from a distance, but no direct contact at all. It is worth remembering how recent this knowledge is, because it shows exactly what we stand to lose. For the whole of human history until 1977, we knew nothing of the beyond firsthand, nothing whatsoever. We could see the stars and guess at what lay between them, but nothing of ours had ever gone there and reported back. Then, within a single human lifetime, we built a craft, flew it past the giant planets, pushed it out through the entire bubble of the sun's wind, and had it send home the first direct word from the space between the stars. The whole body of first-hand knowledge we possess about the beyond fits inside roughly a decade of readings from one dying craft. It is a candle that was lit only moments ago on the scale of our history, and it is already guttering low. When it goes out, we do not lose an old volume we have finished reading. We lose the one opening we have ever had onto the outside, an opening cracked for the first time in the history of our kind that we barely had a chance to look through, and that no one has yet committed to opening again. We were the first generation that could hear the space between the stars directly. We may also be, for a long time to come, the last. I keep coming back to the shape of the choice because it is unusual and it is real. Almost everything a society builds is meant to pay off within the lives of the people who build it, or at least within their children's lives. A probe to the true interstellar medium is not like that. It would take so long to get out there that the people who launched it would very likely be gone before it sent its first reading from the far side. To build it is to work on purpose for the benefit of a generation you will never meet, on a question you will never see answered. That is a strange and demanding thing to ask of any society, and it is genuinely uncertain whether ours or any would choose to do it. It asks us to value the knowing over being the ones who know. And underneath the practical question there is a quieter one about what kind of species we mean to be. For a few decades now, we have been able to listen to the universe from inside it, to hold a real ear out beyond our own bubble and hear the space between the stars directly, rather than only studying it from within our shelter through the instruments back home. That is a genuinely new thing in the history of life on this world, and it is about to end, and it will only begin again if we decide it should. We can be a species that keeps a thread out into the dark, that insists on always having something listening beyond the edge. Or we can be one that draws back inside its bubble and studies the beyond only from a safe distance, second-hand, from behind the glass. Voyager made the first of those possible, once. Whether it stays possible is not a question about a machine, but a question about us, and it is still, for now, unanswered. And that is precisely what is about to happen. No other spacecraft is out there in interstellar space. None is being built and readied to follow. So when Voyager falls silent, we do not reach a finished understanding of the beyond. We stop mid-stroke, the pen lifted in the middle of a line, with the map half drawn and no plan in place to pick the pen back up. The density was still rising along Voyager's path when we lost the ability to follow it. The craft was perhaps only just reaching the clean, undisturbed interstellar space beyond the muddied border, the very region we most wanted to sample, right as its instruments began going dark. We were getting our first proper look at the true beyond at the exact moment our one eye out there started to close. And once it closes, the next direct reading from outside the heliosphere might be decades away, or longer, depending on choices we have not yet made and may never make. Here is the part that I find genuinely hard to sit with. The beyond does not go anywhere when Voyager goes quiet. All of it remains exactly where it was. The interstellar gas is still humming its faint, steady note. The cloud is still pressing on our shield. The density is still rising off in the direction Voyager was heading. The magnetic highway, the muddied border, the whole strange country at the edge of the sun's realm, all of it is still out there, exactly as real as it was, still changing as the sun sails on into new clouds. The only thing that changes, on the day the voice stops, is that we can no longer hear any of it. For a stretch of years, and perhaps far longer, the space beyond our bubble will go on being strange and structured and active, and there will be no one out there listening, and no way for us to know what it is doing. We will be back to guessing at the beyond from the inside of our bubble, the way we did before 1977, except that this time we will know, precisely, what we are no longer able to hear. There is a hard irony in it that I keep turning over. The farthest, loneliest, most isolated thing our species has ever made. A craft so remote that its own voice takes a full day to reach us, so cut off that it cannot be helped and must fend for itself in the dark, is also the only thing that has ever told us, firsthand, what is actually out there beyond our star. Its isolation is the whole reason it is valuable. It went where nothing else has gone, and so it alone can report from there. And so, when it dies, that report simply ends, and no other voice replaces it. We built a single thread out into the beyond, one thin line of contact with the space between the stars, and we are about to let it go. Not out of any decision, but simply because the warmth that carries it is running out, and we did not build another. I will mark the one honest opening in all of this, because it is real. How long the silence lasts is not fixed by physics, but by us. We could choose to build a successor. We could decide that keeping our senses in the beyond is worth the cost and the wait, and start now, so that the gap is decades rather than centuries. Or we could let it lapse and go blind out there for a very long time, and perhaps forever, if the will never comes. The silence is coming for certain. Its length is the one part still in our hands. That is the choice Voyager leaves us with as its own voice fades, and it is not a choice about a machine, but a choice about whether we want to keep listening to the universe from the inside of it, or only from behind the glass of our own small bubble, forever. I keep coming back to that moment in 2012, when the ordinary particles fell away, and the cosmic rays came flooding in, and a machine we built told us, from 18 billion kilometers off, that it had crossed into somewhere we had no name for. We have learnt since then that the beyond is not empty. Instead, it is denser than the bubble we live in, threaded with magnetic fields and turbulence, and it hums, faintly and steadily, a sound Voyager still hears and still sends home. That first unnamed region was not the last of them. Many more have followed, and Voyager is still crossing into places no instrument has ever been. But here is the truth I cannot put down. Everything we know about the outside of our own bubble, every direct fact of it, comes from two dying probes running on the last of a fading warmth, down to their final instruments, whispering back on a signal weaker than the bulb in a household refrigerator. When that whisper stops, and it will stop, within years and not centuries, the map simply ends. Not because we reached the edge of anything, but because our one voice out there went quiet, and there is nothing built to take its place. We will still be here, and the beyond will still be out there, humming to itself in the dark, and for the first time in 50 years, no one will be listening. The farthest, loneliest thing we ever made is also the only thing that ever told us what is really out there, and it is running out of time. If you would like more nights out at the edge of the map like this one, subscribing is what keeps them coming. Sleep well.